Hello everyone, I'm glad to be invited to the conference. I'm from Dalian Maritime University, focusing on machine learning and smart healthcare. Now I will expand on my research, which will be presented in 5 areas. The first one, area research background, and the second area, research objectives. The third area, research significance. And the fourth area, research methodology. The fifth area, results. Now I will talk about the first area, research background. In this stage, renal disease has become a global public health problem, and maintenance hemodialysis is one of the more important treatments. The number of patients with MHD continues to grow, and the patient population is huge, with estimates of the number of patients requiring hemodialysis treatment range from 4.9 million to 7.08 million worldwide. Therefore, the number of MHD patients is large, and the key research is needed. Hemodialysis is the need for venous intubation or establishing an arteriovenous fistula, draining the blood from the body through the blood purification filter composed of hollow fiber. After removing the excess water and the toxin in the body, and then sending the purified blood back to the body, you will need to come to the hospital 3.5 days a week for treatment. Secondly, I will talk about the research objectives. Currently, the analysis of all-cause mortality in maintenance hemodialysis patients is mainly done using traditional statistical methods such as Cox regression and models Kaplan-Meier survival curves. Cox divided into single factor and multi-factor analysis, and Kaplan-Meier methods can analyze patients can be based on a single factor to plot the patient's survival curve so as to determine the impact of characteristics on patient mortality events. However, traditional medical methods such as these have limitations in the analysis of patient mortality. One being the limitation of such methods for the analysis of large samples of data, and the other being that such methods are useful for all patients, but do not analyze individual patients. And also for statistical methods such as Cox regression analysis and Kaplan-Meier, which are important tools for analyzing all-cause mortality in patients. However, most of the methods of this type have certain requirements or assumptions about the data, and models are built in an explicit mathematical form to test hypotheses based on the distribution of the data. However, in the real world, a limitation mathematical formula may not explain the distribution of the data to make hypotheses and test on each. Machine learning, on the contrary, use cross-validation to test and judge the results of the analysis. Therefore, compared with traditional statistical method, machine learning has a more accurate prediction effect, and its analysis results are more easily understood. So, thirdly, I will talk about the research significance. One, machine learning is capable of handling large data where traditional medical statistics has shortcomings. Two, the determining factors that have an impact on all-cause mortality of patients for further study. Three, prediction of all-cause mortality of patients. Next, I will talk about the research methodology. In this paper for machine learning algorithms, random forest algorithm, support vector machine algorithm, and also algorithm and logistic regression algorithm are used to construct a prediction model for all-cause mortality in maintenance and dialysis patients. One random forest algorithm. Random forest is a supervised learning algorithm consisting of a series of independent decision trees trained by multiple back-end interrogative learning techniques suitable for regression and classification. In the 1980s, Bromman invented the classification tree algorithm, which reduces the computational effort by repeatedly the dates for classification or regression. 2001, Breman combines the classification trees into a random forest. Random means the use of variables and data to generate many classification trees and then aggregating the results of classification trees. Random forest improves the prediction accuracy without a significant decrease in computing power. Random forest is insensitive to multivariate covariance, more robust to missing data and unbalanced data, and can predict well the role of up to several thousand explanatory variables, and is known as one of the best current algorithms. Two, support vector machine algorithm. Support vector machine algorithm is a supervised learning method that can be widely applied to statistical classification as well as regression and regression analysis. It's a mapping of vectors into a higher dimensional space where maximum interval hyperplane is created to hyperplane parallel to each other built on either side of hyperplane separating stage. As the separation hyperplane maximizes the distance between the two parallel hyperplanes. Thirdly, Alabos algorithm. Similar to the random forest algorithm, the principle of the Alabos algorithm is to combine multiple if classifier by certain methods to form a strong classifier. The algorithm is implemented by an iterative method. In the implementation of the algorithm, one way classifier is trained at a time, and in the next training, the last chain weak classifier is used for iteration. For logistic regression algorithm, similar to linear regression, the logistic regression algorithm is a classical binary classification algorithm, and the algorithm is implemented by adding a sigmoid function to the results of linear regression, transforming the linear regression results into results between 0 and 1. To evaluate the performance of the model, we introduce the confusion matrix. The formula is shown in the figure. First, I will talk about the results. The 4 models were trained to obtain the confusion matrix. The random forest algorithm is greater than the remaining 3 algorithms in terms of accuracy, precision, recall, and alpha score, and the AOC score. All the 5 metrics are above 90%. As we can see from the figure, among the AOC scores of the 4 models, the AOC scores approximating to 1 with better prediction performance. And in the training of random forest and adverse model, the importance of each influence factor we obtained, and it was ranked to extract the features and that have a greater impact on all-cause mortality. And the findings from a study of all patients, random forest and adverse algorithms were used for the analysis of the importance of characteristics of all patients, and both reached constant conclusions in the analysis of the importance of most characteristics. And the experimental results showed that in the patient in population, the characteristics that had a greater impact on all-cause mortality were age on dialysis, age, albumin, potassium, cardiac ultras, and so on. It has been found that age, device, albumin, sodium, and so on are associated with all-cause mortality in patients. According to a related study, malnutrition is one of the complications of magnesium dialysis patients, and the further prognosis and serum albumin level is an important factor in determining the nutritional status of patients. Therefore, the study of serum albumin levels can have significance for the prognosis of patients. It has been found that the important features derived from the training can be focused on for further studies. When the patient population was divided into 4 groups according to age, the importance of certain features fluctuated widely across age groups. Features that showed an overall increasing trend in importance with increasing age were calcium, pre-sodium, post magnesium, phosphorus, phosphorus, pre-phosphorus, post-phosphorus, and urea. The features that showed an overall decreasing trend and in importance with decreasing age were pre-creatine and so on. And in this paper, the importance, ranking, and analysis of characteristics related to all-cause mortality of all patients, as well as maintenance hemodialysis patients of different age and genders were performed, but the classification of patients were not detailed enough. Therefore, that's all my want to say. Also, do you have some questions? Thank you.